So we're going to begin on page 1, question 1. And I will start by zooming in here if I can. Okay, I cannot. So I'm looking at number 1. I want to write this in simplest radical form. And so I'm going to simplify each part, A and B, and the numbers separately. So I know that the third root of -8 is actually just -2. Why is this not drawing on me? Then when I take the third root of a to the 6th, remember that that is a to the 6th divided by 3, and 6 divided by 3 reduces to make a to the 2nd power. And when I think of the b is the 5th power, and then that 3 in the pocket is the divisor of the exponent. And so 5 is not going to divide by 3 evenly. It's going to give me 1 2/3 when I think of it as a mixed number instead of this improper fraction. So that really just means that 1b is going to come out, b to the 1st power. And then I'm going to have 2 b's left over in the third root, b to the 2nd power. So that all together, that would add up to the original b to the 5th power. Do you guys remember doing this a few months ago? Okay. And so this is my final answer. I don't have to worry about the absolute value bars on this one because it was a third root, which is an odd index. So as I look over at question number 2, I'm seeing that I need to multiply these radicals, and it's a 4th root, which is an even index. And so that could have slightly different rules. Let's see if I can scroll over. Yes. So I'm looking at this one here, and I'm going to begin by multiplying 20 and 8, x to the 2nd, and x to the 3rd, etc. So I'm just going to do that first. So I've got 160. Okay, that's going to be x to the 5th, y to the 12. Okay, just switch colors, and then z to the 4th power. So far, I hope you guys agree. This is now all together in the 4th root. Okay. I'd love to know why it just changed colors on me, but I like this color better, so that's good. So the 160, that's a little bit tricky. So, oh, awesome. I'm looking for 4 of a kind. That's going to be 16 times 10, right? And I like that. So 16, the 4th root of 16 is 2. And then I'm going to have this leftover 4th root. The 10 did not have a 4th root, so that's going to be left over inside the root when I simplify it. Then I'm looking at that 5. So just like I did before with the third root, I'm thinking of dividing that 5 by 4. And I know that that's going to be x to the 1 1/4 power when I write it as a mixed number. So that tells me that the x is going to have 1x come out, and then the 1/4 will be left behind. So x to the 1st power here, and also an x to the 1st power inside here. So whenever we don't have a number that divides in evenly, some part of it is left behind in the radical. Okay, then my y, it does look like a g right now, just because my pen was so thick at the time. When I divide 12 by 3, nope, why would I divide by 3? Oops. I need to divide it by 4. That was just, I'm thinking of last problem. 12 divided by 4 comes out evenly as a 3. And we're going to put a little star by that. That was an even index, and this is an even exponent of 12, and then it came out as an odd exponent, so we need to use absolute values around the y. Even, and odd. And that's even index, even exponent, and it's odd exponent, and it's O for outside also. All right, then I'm looking at the z. The same thing's going to happen though. It's going to be 4, which is even. It's the even index of 4. And when I divide that, it's z to the 1st power. So actually, when I erase this, include the z inside there. And now this is my final answer. So that looks a little bit messy. I'm going to write it over here. 2 without those exponents. X, absolute value of y to the third, z, 4th root of 10x. Great. Moving on to number 3, probably another radical problem. Let's take a look. Aha. So here in this problem, I'm not multiplying. I want to combine like terms, and I can add together radicals if they have the same index, which all of these have an index of 2, and they have the same number inside the radical or same radicand. So let's start by simplifying all of these. 20 is 4 times 5. And I think of 4 times 5 because the square root of 4 is 2. So I'm thinking of both of these inside the radical when I'm thinking about it. So the square root of 4 is 2, and that's going to be multiplied with the 2 outside to give me 4 rad 5 for that first term. The minus 5 rad 5 will not simplify further, so I'm just going to write it down again. So then I'm thinking of the 45. I want a square number, and I think I want 5. And so what this works out nicely to 9 times 5. And the square root of 9 is 3. So this is plus 3 rad 5. Now with the 125, if I divide that by 5, oh yeah, that works out good. So that's going to be 25 times 5. And the square root of 25 is going to be 5. And I multiply that with the 3, giving me 15 rad 5. So I love it. All of these have rad 5, so I can add all 4 of these together to simplify to a single rad 5. I just need to know how many. So 4 minus 5 is -1, plus 3 is 2, plus 15, so a total of 17 rad 5. How are we doing so far? All right, cool. So now let's take a look at our next group of different types of radicals. So I'm seeing in number 4 that we have a negative. Ew. So I hate this. Whenever we have a negative inside the radical, that means that our answer will simplify to have the imaginary number in it. And I'm getting out my calculator because that's a big number. Obviously, I know it's divisible by 10, but I'm going to start by simplifying the -1. And then I'll simplify that 675, right? With the 0. And I want to factor that. So I don't know. I don't want to wonder if 49. 6750. Nope. 6750 divided by 10. Give me 675. Well, 25 might be in there. Right? That's going to give me 27 and 25. Oh, wait, no, it's two. Let me do that again. 675 divided by 25. Okay, yep, I did that right. So it's a square root, so I'm looking for 2 of a kind. So right here, the 25, that's good. We know the square root of 25, and then inside of 27, I know that there's another perfect square, and that's going to be 9 and 3. So I'm going to circle the 9. So I'm just earmarking the ones that I know are going to simplify further. The 3 and the 10 will not simplify further. They don't have any square factors, even when I multiply them together. So the square root of -1 is the imaginary number I. Then these 2 are going to come out. This is a 5 and this is a 3. So that's going to be 15I on the outside. Those ones simplified out. And then the 3 and the 10 don't simplify, so they're going to remain in the radical as rad 30. And that's going to be my final answer. Great. So I just have to remember, if there's a negative, I'm just going to remember that I is going to be in the answer. But the negative is inside the radical. So then starting here at number 5, I see 2 binomial radical expressions. And in that case, I'm going to use the FOIL method, right? And that's just first, outside, inside, last, to remind me that I need to multiply 4 times. So 5 times 1 is 5. That's first terms. These are the outside terms. And so when I multiply these, I multiply the matching parts. 5 and 3 are both outside of the radicals, so they get multiplied together as negative 15. And the rad 6 stays as a rad 6. So that was first outside. Now these ones are the inside. I multiply these together. The 1 is on the outside. The rad 6 stays as a rad 6. And now I'm going to do these two. So the negative 3 is the only thing on the outside that stays on the outside. And it was rad 6 times rad 6. And I multiply the 6's together since they're both being multiplied and they're both inside to get 36. So 36 is a perfect square. That's going to turn into negative 3 times 6, which is negative 18. So I'm going to add together 5 minus 18, and I'm going to get negative 13. And then separately, I'm adding these radical expressions together. Negative 15 plus 1 is negative 14, and the rad 6 does not change at all. It stays as a rad 6. So that was really fun. It looks like I've got another problem over here. Number 6 is similar. I can see that number 8 is going to be a similar pattern. It's 2 binomials. But let's take a look at number 6 first. So number 6 is an example of 2 complex numbers being added together. These are really easy. We just add the matching parts. So I'm going to add 4 and 2, and I'm adding because it says plus. So 4 plus 2 is 6. Awesome. Now separately, I'm going to add positive 7 and negative 5. And that's going to be positive 2, and it's 2i. And the proper form is a plus bi. So the imaginary part wants to come second. And so when we simplify our next ones, we're going to follow that same type of pattern. So let's look at our next line here. Coming on over to problem number 7. Oh, it's just like number 5. We're again going to use FOIL. So on 7 and 8, we're going to use FOIL. So the thing here is that we've got to remember a little bit about the imaginary number I. So let's start by multiplying these first terms. That's going to be 44. Then the outside, that's going to be plus 11 times 3, 33i. Now the inside. So that's just positive 4i. And now the last, that's going to be positive 3. And there are 2 i's, so we write that as I to the second power. So here I'm going to put a star, and this is I to the second power, right? That's going to be the square root of negative 1 to the second power. Just as a reminder of us, what's going on behind the scenes, and the square and the square root cancel each other out. So the answer to this is that it's equal to negative 1. So here I've got the I squared. I'm going to write this as plus 3. And instead of I squared, I'm going to write times negative 1, which simplifies to negative 3. So this last term no longer has the imaginary number I in it. It's simplified out. And so I'm going to combine the 44 and the negative 3 to get 41. Separately, I'm going to add together the parts that still have I, 33 and 4, to get a positive 37i. So number 8, we've got the same thing, but the pattern of number 8 is slightly different. The pattern of number 8 is that it's 3 plus 2i and 3 minus 2i. Those are called conjugate pairs. And you might recall conjugate pairs from your Unit 4 test. And so what happens with the conjugate pairs is there's a special pattern that results in the pattern of the answer. Because of how this works out, there should be no imaginary numbers left over when we're all finished. So let's do that FOIL first. That's going to be 3 times 3, 9. Outside, 3 times 2 is 6i. inside, negative 6i, last, negative 4i to the second power. I remember from just last problem that I to the second power is negative 1 times negative 4. That's going to give me the final result of negative times a negative, positive 4. So adding positive 4 and 9, I get 13. And then look at these middle terms. I have a positive 6i and a negative 6i, a perfect cancellation. My final answer is just 13. So with conjugate pairs, we expect that pattern to result where we end up getting a cancellation of the middle terms. Let's take a look at problem number 9. Okay, 9 is I to the 63rd power. So this is just a single imaginary number that we want to reduce to either I, which comes from I to the first power, which we would just write as I. We recall that I to the second power is equal to the value negative 1. And these are the two that you need to know. If you know these two, you can figure out every subsequent value for I. So considering this, I've got I to the 63rd power. This works in patterns of 4. So I divide 63 by 4. And that's going to give me either remainder 1, remainder 2, remainder 3, or no remainder. So this for remainder 1, it's I. For remainder 2, it's negative 1. For remainder 3, that would come from 1 times 2, so that'd be negative I. And then for no remainder, that's I to the 4th power, that's negative 1 times negative 1, which is positive 1. So I know 63 does not go into 4 evenly. I know that it's 60 plus 3, and 60 goes into 4 15 times, and so I have my remainder of 3. So that tells me that this has the pattern that the answer is negative I. So it's very important that you understand what is the definition of I as the square root of negative 1, because if you know that idea, from there you can do the work to figure out all iterations of I. There are only 4 possible answers. All right, cool. Looking at number 10. So we're still looking at radicals here, but here we see that the radical is doing something totally different than before. The radical is in the denominator. All we need to do is rationalize. Radicals are not allowed in a denominator, and so I'm going to multiply by a radical. And what should I multiply radical 2 by to get a whole number? Well, by radical 2. This is just the number 1 because it's rad 2 divided by rad 2. And so I get 10 rad 2 divided by rad 4, right? That's the work behind the scenes. And the square root of 4 is 2. So I have 10 rad 2 over 2. Well, as I see that 10 and 2 are both outside of the radical. And so because they're both outside, I am going to simplify them further to give me my final answer of 5 rad 2. So we're not allowed to leave radicals in the denominator. And so when we see it, we need to multiply by a special 1 so that the fraction value is unchanged, so that we can have the radical in the numerator. Okay, 11 is a rational equation, and we're at a totally different type of work here. You can see that this is a trinomial divided by a trinomial, and you need to factor. We're going to factor before anything else. So this is meant to be the fast factoring because these are both x squared. So I would hope that at this stage, you're able to factor really quickly in your head to 2 binomials. So for the top, in my t-chart, the thoughts that I'm thinking are negative 1 and negative 6 needs to multiply to negative 6 and then add to negative 1. What are the values that do that? Well, it would be 2 and 3. 2 times 3 is 6. These numbers are 1 unit apart. The 3 needs to be negative so that when I add them together, I get negative 1. So this factors to x positive 2, x minus 3. In the denominator, our t-chart has -6 that we want to add to and +9 that we want to multiply to. So of course, for 9, I'm thinking of 3 and 3, but 3 plus 3 would be +6. So in order to get -6, I actually need both of these to be negative because a negative times the negative is a positive. So that's going to be x minus 3 and x minus 3. This is reminding us, oh, if I was solving for x, the answer could not be 3 because 3 minus 3 is 0. However, what I'm looking for here is a perfect match in the top and the bottom, and I found that. I reduced them just by slashing them out, and I've got my final answer of, x plus 2 over x minus 3. This cannot be simplified further. This is a unique binomial divided by a different unique binomial. Great. Looking at number 12, I see a similar idea. I've got binomials. I noticed that there's a monomial x. I've got a trinomial, and I have another binomial. So I'm going to begin factoring. In this first fraction, I'm going to factor by taking out the GCF. This factoring is really fast and easy. I'm just dividing both of these by the number 6, and that gives me 6 parentheses x plus 2. On the second binomial, I'll start there because that's going to be fast and easy. I can divide both of these by the common letter x, and then what would come out would be x plus 6 left over. All right, now for the numerator, I'm noticing that those are all even, which is nice. So first, I'm going to divide them all by 2. That gives me 2x squared plus 13x plus 6. And the 2 came out very good, awesome. Now I need to factor that trinomial. As I'm looking at it, I see that it does not have a lead term of x to the second. It has 2x to the second, so I have to do the long form factoring. So I'm going to show my work here. And I need 2 times 6, I needed to multiply to 12, and that's a positive 12. And then I needed to add to the middle of positive 13. So considering that 13 is larger than 12, I want it to be 12 and 1. So that just means that the middle terms are going to be 12 and 1. So I'm going to have 2x squared plus 12x plus 1x plus 6. So I split the middle term into the 2 factors that I found, multiply to the right number and add to the right number, and then I draw the fence, cutting the problem into 2 equal halves. And then I'm going to factor the GCF out, just like I did in those binomials. So in the first 2, I can definitely take out a 2x. And when I do that, I'm left with x plus 6. In the back, I can't take out any specific value, so I'm just going to write plus 1 and then x plus 6. Because the binomials match, I feel happy and good. So I've got, oh my gosh, 2x plus 1, x plus 6, and then I'm reminded that I have a 2 out front. So that was a lot of work. So if I write this all nice and easy next to each other, that would be great, but I'm just going to slash these out so I don't get confused. Now I'm looking for exact matches in the top and bottom, and I have first these x plus 6s are going to cancel out. The 2x plus 1 is not going to cancel out, so I know that that's going to be in the answer. Then I have the 2. That's going to cancel out with the 6, turning the 6 into a 3. So there's going to be a 3 left over in the bottom. Excuse me, I need to scroll up a little bit. Oh, no. Oh, darn. Okay. So now I'm going to cancel out this x with this x. So those x's canceled. And I'm looking, so I already got the 2x plus 1. I've got the 3. So the x plus 2 is also in the bottom. This is my final answer. So I canceled out all my exact matches. Great. Let's take a look at a few more problems. Oh, we might finish the whole first page. How wonderful. Okay, so 13, I'm looking at this and I see that I have to divide. So divide means to multiply by the reciprocal. So I'm going to begin by switching this around. X squared plus 4x minus 32 and x squared minus 16. The way that division works, and then as I do that, this changes to multiplication, is we multiply by the reciprocal, which just means switch the top and bottom. So I've got some factoring to do. I'll start with the binomials. Looking at these both have a GCF of x. So I'll take the x to the outside of parentheses and divide both of those to give me x plus 4. In the denominator, this binomial has a common factor of 2. That's going to give me x plus 8. So I factored those. I kind of just like to leave them out of my mind. The numerator, I'm thinking of, okay, negative 32 and positive 4. I know that's going to be 8 and 4, and it looks like the 4 needs to be negative. 8 minus 4 is 4. So that's going to give me x plus 8 and x minus 4. I use the fast factoring here because it was just x squared, whereas the previous problem was 2x squared. 2x squared or 3x squared means so much more work. All right, and then in this binomial, there's no common factor. I see that it's x squared and there's no x. So this is the special pattern. It's called the difference of two squares. So if I'm making my t-chart, the b value, the middle term is 0, and we need to multiply to negative 16. And so that's 4 and negative 4. 4 minus 4 adds to 0, and that will multiply to 16. So that's how I get x plus 4 and x minus 4. So you see that I began by factoring all 4 parts. Now we're going to look for our cancellations. So the x does not cancel. It stays in the final answer. The x plus 4 does cancel. Moving right along, the x plus 8 cancels. Next, the x minus 4 cancels, and all that's left in the denominator is 2. So my final answer is just x divided by 2. I had left extra space there that I didn't end up using. Cool. And we're going to look at 14. Okay, so this one we're trying to add these two fractions. So again, I need to factor the denominators so I can see what the factors of the denominators are because I need a common denominator. So I look at this, I need to add to 2 and multiply to 1. That's going to be x plus 1 and x plus 1, right? 1 and 2. I hope that's easy for you. And then on this side, I'm noticing that there's a GCF. I'm going to take that 4 to the outside of parentheses. Then I'm going to be left with x squared minus 1. So this x squared minus 1 is a similar pattern to the x squared minus 16. This time we want to multiply to negative 1 and add to 0. So it's going to be 1 minus 1. So this factors to 4, x plus 1, x minus 1. So my LCD, least common denominator, is going to contain the number 4. It's going to contain the x plus 1. It needs to have an additional x plus 1. And it needs an x minus 1. So considering all that, I need to multiply each term so that they have the exact same denominator. The first term needs a 4 and the binomial x minus 1. The second term has the 4, the x plus 1, the x minus 1, but it doesn't have 2 x plus 1s, so it needs the x plus 1. So when I think of this, I'm going to think of it as 4x times x plus 1, and I'm going to distribute that to get, where will I write my answer? I'm going to write it right here. and that numerator 4x to the second power, and then plus 4x. And then with the 3, I'm going to do plus 3x, and then plus 3. So that's my numerator here. Adding these middle terms together, I've got 4x squared plus 7x plus 3. Oh, and that's the bell. I'm considering 12 and 7, and I don't think that that's going to, oh man, that does factor further. So I'm going to have to keep going and factor this. So this problem is not finished, but our class period is. So have a great day. And I'll see you guys tomorrow.